So for member 2, we don't have to rotate it at all. The loads just look like this. So 3 important points, 2 cuts. The first cut is for x between 0 to 0.5. So you have the 10,000 Newton force up, and then you have tension, shear force, and bending moment. And this distance is x. So Newton's second law is 0, 10,000 plus T0 plus 0 negative V is equal to zeros. And the rotational equation, since we're computing at about this point, there's no moment produced by that 10,000. So we just have m minus Vx is equal to 0. So T is equal to 0. V is equal to 10,000. And m is equal to 10,000x. And then the second cut, we have the 10,000. This time we have the 20,000 down. Tension, shear force, bending moment. And this distance is x. So Newton's second law says 0, 10,000 plus 0, negative 20,000 plus T0 plus 0, negative V is equal to zeros. And the rotational equation says still no moment produced by this, but there is a moment produced by the 20,000 down. That has a moment arm of 0.5, and it's clockwise. So negative 10,000 plus m minus Vx is equal to 0. Okay, so T is equal to 0. V is equal to negative 10,000. And the bending moment is equal to let's see, negative 10,000 x plus 10,000. It's positive Vx, but then V is negative. That's different than what I got in my notes. Did anyone get something different on that one? I guess that should be right. Yeah, okay. So these diagrams look like this. The tension is 0. The shear force is positive 10,000 and then jumps to negative 10,000. And the bending moment goes up with a slope of 10,000 to the midpoint and then goes down back to 0 over here. And how do I know those should end up at 0? How they should start at 0 and end at 0 without looking at the formulas? Yeah, there's no couple at either end. Okay. All right, well, let me just do the last one. We're running out of time. So remember 3. This is the one where the rotation is a little bit, using a rotation matrix makes a little more sense on this one. We have loads of, let's see, 0, 5,000. Then 0, negative 10,000. And then 0, 5,000. In order to, we want to take a coordinate system like this and rotate it to one like this. See what I mean? So what's the rotation that we want here? Yeah. So the rotation matrix is cosine of negative 45, sine of negative 45, negative sine of negative 45, and cosine of negative 45. And if you multiply those out, you get a member with a force on this end of negative 35, 35.5, positive 35, 35.5. Then in the middle, you get 7071.1, negative 7071.1. And then at the end, negative 35, 35.5, positive 35, 35.5. So again, there are 3 important points, so 2 cuts. The first cut is for x between 0 and the midpoint, which is this, 0.7071. So you have 35, 35, 0.5, what did I say? Negative, and then positive. Tension, shear force, and bending moment. And this distance is x. So Newton's second law says negative 35, 35.5, positive 35, 35.5, plus T0 plus 0 negative V is equal to zeros. The rotational equation, there's no moment produced here, so you just have m minus Vx is equal to 0. So the tension is 35, 35.5. Shear force is 35, 35.5. And the bending moment is 35, 35.5x. So x, that's for x between 0 and 0.7071. And then the second cut for x between 0.7071 and 1.414. Negative 35, 35. Positive 35, 35. This time we also have the force of 7071, negative 7071. Tension, shear force, bending moment. That distance is x. So Newton's second law says negative 35, 35, positive 35, 35, plus 7071, negative 7071, plus T0, plus 0 negative V is equal to zeros. And the rotational equation, we have negative 5,000. That's produced by this vertical component of this force. Plus m minus Vx is equal to 0. So we have tension is equal to negative 35, 35. Shear force is equal to negative 35, 35. And bending moment is equal to negative 35, 35 x plus 5,000. Okay, so, sorry, this is almost done. So there's the tension, shear force, bending moment. For the first half, we have 35, 35 for the tension and the shear. And the bending moment goes up to 2,500. And then for the second half, we have negative 35, 35. So there, there, and this goes back here. Okay, so the maximum, let's see. The maximum bending moment is this 5,000 right at the midpoint of member 2. Okay. The maximum shear force is 10,000 or the negative 10,000. We don't really care about the sign. Anywhere along member 2. And the maximum tension is, where was that? 15,000 in the second half of member 1. Okay. And that's information you can then use to say, like, you built this structure, where are the places that you're concerned about fracture? Anyone have any questions? Yep.
If our compression was bigger than our tension in that, would that still be a max?
So, yeah, you know, that actually sort of depends on the material. Usually, for engineering materials, steel or whatever, then yeah, you just take the absolute value. Okay, thanks. I'll get the solutions up to all the problem sets you need for the exam, and look on D2L for more information about the exam. I'll get that up right away.